According to the National Electrical Code, specifically Article 680.27, A1, a dedicated branch circuit is required for all pool pump motors and other fixed pool equipment. Further, Article 680.27, A2 of the National Electrical Code states that the branch circuit must be supplied by an individual circuit breaker or fuse disconnect. Article 408.3 of the National Electrical Code requires that subpanels be rated for the sum of the currents of all circuits supplied by the panel. Aside from code issues, there are some other issues to consider. Firstly, voltage drop. Installing a subpanel off another subpanel can introduce voltage drop. This can affect the performance of the pool equipment. Secondly, circuit capacity. The existing 50 amp subpanel may not have enough capacity to support the additional load from the pool equipment. Thirdly, grounding. Proper grounding is critical for pool equipment. The subpanel must be properly grounded and bonded to the pool structure. Based on the code and other issues mentioned, it is not recommended to install a pool subpanel off an existing 50 amp subpanel. Instead, it is better to run a dedicated feeder circuit from the main breaker panel to a new subpanel located in the shed where the pumps will be installed. This ensures that the pool equipment has a dedicated circuit and meets all applicable code requirements. It is highly recommended to consult with a licensed electrician to properly design and install the electrical system for the pool. They will ensure that the installation meets all applicable codes and standards and minimizes any potential safety concerns. Electrical subpanels serve as distribution points for electrical power, branching off from the main electrical panel to supply power to specific areas or equipment. They enhance electrical system efficiency and safety by isolating circuits, simplifying maintenance, and preventing overloads. Subpanels are crucial in residential, commercial, and industrial settings for managing power distribution effectively. The National Electrical Code, or NEC, provides comprehensive standards for electrical installations in the United States. It covers various aspects of electrical wiring, protection, and safety to minimize fire and electrical hazard. Compliance with the NEC is essential for ensuring safe and reliable electrical systems. Voltage drop occurs when electrical current flows through a conductor, causing a reduction in voltage along the conductor's length. Excessive voltage drop can lead to inefficient operation of electrical equipment, overheating, and potential damage. Minimizing voltage drop is crucial for maintaining optimal performance and safety in electrical systems. Grounding is the process of connecting electrical equipment and systems to the earth, providing a path for fault currents to flow back to the source. Proper grounding protects against electrical shock, minimizes the risk of equipment damage, and ensures the reliable operation of electrical systems. Grounding is a fundamental safety measure in electrical installations. Bonding involves connecting different metallic parts of an electrical system to create a low impedance path for fault currents. Bonding helps equalize electrical potential, reducing the risk of electric shock and preventing the buildup of static electricity. Bonding is an essential safety practice in electrical systems, especially in areas with sensitive electronic equipment. The amperage rating of a circuit breaker determines the maximum amount of current it can safely handle before tripping and interrupting the circuit. Selecting the appropriate amperage rating for circuit breakers is crucial for preventing overloads, protecting electrical equipment, and ensuring the safety of electrical systems. Exceeding the amperage rating can lead to overheating, fire, and damage to equipment. A dedicated circuit is an electrical circuit that serves only one specific appliance or piece of equipment. Dedicated circuits prevent overloading, minimize interference, and ensure reliable power supply to sensitive devices. Dedicated circuits are commonly used for high-power appliances such as refrigerators, air conditioners, and electric stoves. When dealing with electrical installations near pools, it is crucial to adhere to stringent safety standards. These standards are put in place to mitigate the risk of electrical shock, which can be particularly hazardous in wet environments. Ground fault circuit interrupters, or GFCIs, are vital safety devices that monitor the electrical current in a circuit. If a GFCI detects an imbalance, indicating a potential ground fault, It quickly cuts off the power to prevent electrical shock. Ensuring that all pool-related electrical equipment is properly grounded and equipped with GFCIs is paramount. This measure helps to prevent stray voltage from energizing the water or surrounding conductive surfaces, which could pose a significant risk to swimmers and anyone in the vicinity of the pool. Electrical safety near pools is not just about following code requirements, it's about creating a safe environment for everyone to enjoy the pool without the worry of electrical hazards. Regular inspections and maintenance of the electrical system are also essential to ensure ongoing safety. Pool pump motors are designed to circulate water through the pool's filtration system, keeping the water clean and clear. These motors are typically powered by 240 volts alternating current, or VAC, and can draw a significant amount of current. The current draw of the motor depends on its size and efficiency. It is essential to ensure that the circuit supplying the pool pump motor is adequately sized and protected by a circuit breaker of the appropriate amperage rating. Overloading the circuit can cause the breaker to trip, interrupting the operation of the pump and potentially damaging the motor. Polaris motors are specialized pool cleaning devices that operate using electrical power. They are designed to efficiently remove debris and maintain the cleanliness of the pool. The current draw of a Polaris motor is typically less than that of a pool pump motor, but it still needs to be considered when planning the electrical system for the pool. Like pool pump motors, Polaris motors should be connected to a dedicated circuit with appropriate overcurrent protection. Ground fault circuit interrupter, or GFCI, receptacles are crucial safety devices for pool areas. They protect against electrical shock by quickly cutting off power when a ground fault is detected. It is essential to install GFCI receptacles near the pool to provide a safe and reliable power source for various electrical devices. GFCI receptacles should be tested regularly to ensure they are functioning correctly and providing adequate protection. Pool lights enhance the aesthetics and safety of the pool, allowing for nighttime swimming and creating a pleasant ambience. Pool lights are typically low voltage, but they still need to be installed and maintained according to electrical codes and safety standards. Proper grounding and bonding of pool lights are essential to prevent electrical shock hazards. Regular inspections of pool lights should be conducted to ensure they are in good working condition and free from any damage. PVC conduit is commonly used to protect electrical wiring in underground installations. It is durable, corrosion resistant, and easy to install. When running electrical feeders to a subpanel in a shed, PVC conduit provides a safe and reliable pathway for the wiring. The conduit should be buried at the appropriate depth to protect it from physical damage. Electrical subpanels must be properly rated for the sum of the currents of all circuits they supply. This ensures that the subpanel can safely handle the total load without overheating or causing a fire hazard. When selecting a subpanel for a pool, it is essential to consider the total current draw of all the pool equipment, including the pump motor, Polaris motor, GFCI receptacle, and pool lights. The subpanel should have enough capacity to accommodate the current draw of all these devices, with some additional capacity for future expansion. Overloading a subpanel can be dangerous and should be avoided. It is essential to consult with a licensed electrician to determine the appropriate size and rating of the subpanel. A licensed electrician has the knowledge and experience to properly design and install the electrical system for a pool. They can ensure that the installation meets all applicable codes and standards and minimizes any potential safety concerns. Consulting with a licensed electrician is highly recommended before undertaking any electrical work on a pool. They can provide valuable guidance and ensure that the installation is safe and reliable. The importance of running a dedicated feeder circuit from the main breaker panel to a new subpanel cannot be overstated. This ensures that the pool equipment has a dedicated power supply that is separate from other circuits in the house. This isolation minimizes the risk of electrical interference and ensures that the pool equipment receives a stable and reliable power supply. A dedicated feeder circuit also makes it easier to troubleshoot and maintain the electrical system for the pool. Regular maintenance and inspections of the pool's electrical system are crucial for ensuring its continued safety and reliability. This includes checking the condition of the wiring, connections, and equipment, as well as testing the GFCI receptacles and circuit breakers. Any damaged or worn component should be replaced promptly. It is also essential to keep the electrical equipment clean and dry and to protect it from the elements. Regular maintenance and inspections can help identify and prevent potential problems before they become serious hazards. A feeder circuit is the main electrical supply line that runs from the main breaker panel to a subpanel. It is responsible for providing power to all the circuits in the subpanel. The feeder circuit must be sized appropriately to handle the total load of all the circuits it supplies. The size of the feeder circuit is determined by the amperage rating of the subpanel and the voltage of the electrical system. It is essential to use the correct size wire for the feeder circuit to prevent overheating and voltage drop. The wire size should be selected based on the amperage rating of the circuit breaker protecting the feeder circuit and the length of the run from the main breaker panel to the subpanel. The National Electrical Code provides tables that specify the allowable ampacities of different wire sizes. A circuit breaker is a safety device that protects electrical circuits from overloads and short circuits. It automatically trips and interrupts the circuit when the current exceeds a safe level. Circuit breakers are essential for preventing overheating, fires, and damaged electrical equipment. Circuit breakers are rated in amps, which indicates the maximum amount of current they can safely handle before tripping. It is essential to select the correct size circuit breaker for each circuit to provide adequate protection. Overcurrent protection refers to the use of circuit breakers or fuses to protect electrical circuits from overloads and short circuits. Overcurrent protection is required by the National Electrical Code for all electrical circuits. The purpose of overcurrent protection is to prevent overheating, fires, and damage to electrical equipment. Overcurrent protection devices must be selected and installed according to the requirements of the National Electrical Code. In summary, when dealing with pool electrical systems, several key points must be kept in mind. Firstly, adhering to the National Electrical Code requirements is paramount for safety and compliance. Secondly, proper grounding and bonding are crucial to prevent electrical shock hazards. Thirdly, ensuring adequate circuit capacity is essential to avoid overloads and potential damage to equipment. Fourthly, regular maintenance and inspections are necessary to identify and address any potential issues. Fifthly, consulting with a licensed electrician is highly recommended to ensure a safe and reliable electrical system. By following these guidelines, you can create a safe and enjoyable pool environment. Remember, electrical safety should always be a top priority when dealing with pool electrical systems. Taking the necessary precautions can help prevent accidents and ensure the well-being of everyone using the pool. Electrical work can be dangerous, so it is always best to consult with a qualified professional. They have the knowledge and experience to properly design, install, and maintain the electrical system for your pool, ensuring that it meets all applicable codes and standards. Don't take any risks when it comes to electrical safety. Always hire a licensed electrician for any electrical work on your pool. This investment can save you money in the long run by preventing costly repairs and ensuring the safety of your family and friends. A professional electrician will be able to assess your specific needs and recommend the best solutions for your pool's electrical system. They will also be able to provide you with valuable advice on how to maintain your electrical system and keep it running safely and efficiently. So, don't hesitate to contact a licensed electrician for any electrical work on your pool. It is the best way to ensure that your pool is safe, reliable, and enjoyable for years to come. Remember, electrical safety is not something to be taken lightly. Always prioritize safety when dealing with electrical systems.